So I'm from Statistics and Machine Learning in Linköping University. And my main research interest, and I'm doing a PhD now in statistics, on how to analyze large text data sets, and mainly how we can use large text data sets in the humanities and the social sciences. So that's my background. And I'm going to, I think my talk will be a little bit different than the other one. So I will give a short introduction to what I think is machine learning, and what I see happening in the machine learning field that has implication for the social sciences and the humanities. Especially those fields in social science and humanities that use text as their empirical material, like law, for example, or history, or political science. Oh, I need to start so I know when to stop. So this is one definition I found online. I don't remember where it is, so it should have been cited, but I don't remember where I took it from. So what is machine learning according to my definition, or this taken definition? First of all, it's a type of artificial intelligence. So some people call it narrow AI. AI, as I know it, is like a very broad concept, and machine learning is the narrow part where you use data to do predictions. And the purpose is to use computers to do predictions without explicitly being programmed. So that is one of the main definitions. And to do this, we need to build algorithms. And to do that, we need computer scientists. And I would also say that we need algorithms that can scale to very large data sets. But the purpose is to take those algorithms, input data, and use statistical or probabilistic methods. Often you talk about probabilistic machine learning that are based on statistics, essentially, and how to scale statistical methods to do large-scale predictions for values within an acceptable range. And what is an acceptable range? I mean, this is the purpose of domain knowledge, of social scientists and people in the humanities. What do we want to predict, and why do we want to predict things? So we need computer scientists, we need statisticians to do this machine learning, and we need social scientists and people from the humanities. Or we can have a Renaissance person that can do everything, but I haven't found one yet, because it's a lot of knowledge that you need to keep in one person. So this has a lot of other talks here. People have talked about this. We can see it a lot in technology. Spam filters is one example. Image recognition, Google search engines, and self-driving cars. I read just, I think, 2 days ago that in California now they will be allowed to drive driverless cars without the steering wheel from January. So now it's happening. So the purpose for me is to look into how can we use machine learning techniques to leverage social science or the humanities. And how can we use machine learning tools to automate parts in the research process? Things that we used to have, like, I don't know how you do it, but we used to have students that have to tag things for us. And how can we use machine learning tools instead? So I will not delve deep into this. This has been, other people have talked about this, but I think it's important to state that the reason why machine learning is getting more and more popular is, first of all, we have more and more digital data in different forms. So we can actually use relatively complicated models or techniques because we have more data, so we can fit more complex model to this data than we could do before. And we also have more computational power today than we had just 5 years ago. So we can actually fit those complex model as well, like deep neural nets or whatever we want to fit. So some important developments that I see in machine learning that is of importance for the social sciences that I think of is, first of all, and there are some. We were talking a little bit about this after your speech, and that is that most machine learning algorithms are like black boxes. So we have, I don't know, a lot of data, we have a lot of books, and we have a lot of popularity scores for these books, and then we throw it all into a black box, and we train our model, and out we get a box that can classify a book if it's going to be popular or not. But that's perfectly well in some situation, but what we want to do is understand why the algorithm is classifying one book to be popular and one book to not become popular. And you can see more and more of this coming. So in one of the most prestigious machine learning conferences, NIPS, that will happen in 2 months, they have this workshop now on interpretable machine learning to try to understand how these algorithms works under the hood, so we can understand it. And one part of that workshop will be on social science. So it's a clear connection between interpretable machine learning and social science. So the second thing that I think is important, this has been around for longer than interpretable machine learning, but it's getting more and more. Maybe it's just because I use it a lot, but I think it has quite some importance. So we usually, when we talk about machine learning, we talk about two situations. So first, we talk about supervised machine learning, and that is the classical case. You have some data and you have some labels, for example, to predict. I don't know, to classify an image or predict the book, will it be popular or not? And then you have the true value, and you have your training data, and then you train your model and you classify a new book to be popular or not. So that is supervised machine learning. So in this case, this is a classic data set, iris on different species of orchideae. And here it's supervised, so we know that this is one species, the green is one species, and the blue is another species. But in social science, we often don't have this nice classified data set ready for us. Instead, we have, in my field, when we work with text, we only have a lot of books, or we have a lot of speeches in the parliament, or we have a lot of articles, or we have a lot of documents. And we want to find the patterns in this data, but we also want to find patterns that can answer our research questions. So it's not just doing exploratory analysis, but also find those patterns that are interested for us, but without having to go through all the data and classify it for us. So this is the second thing that I think is important for the connection between machine learning and social science. The third thing is that a lot of those things that we're talking about now, image classification, speech to text, for example, that you can take speech and turn it into textual data, are becoming more and more available as APIs. So ordinary researchers can use a lot of those really advanced techniques in their own research projects. And audio to text, one simple example would be that you would like to analyze the discourse in radio during the 20th century, for example. That would have been really difficult to do 10 years ago. Today we could actually use, for example, Google's speech-to-text analysis to turn all this radio broadcast into textual data that we then could use to follow the discourse over time. We have machine translation is another example that we can use. If we have a lot of data, now it's a little bit geared towards text, since that's what I'm working with. But we could use machine translation, for example, if we have a lot of documents in different languages, to turn them into one language if we want to model or analyze it. It's not perfect. Those methods are not perfect, but it's probably both cheaper and easier than to do it any other way. So it can leverage us as social scientists quite much. So what I'm going to do now with my speech, this is what I see and what I've been working a little bit with, is I'm going to give two examples of projects that I've been involved with and is involved with that have make an example of all these three aspects more in practice. So the first question, a work I do together with two political scientists, is we want to study what happens in the Swedish parliament when the Sweden Democrats enter the parliament in 2010. What happens with the discourse? And also we want to see how do other parties react when the Sweden Democrats enter the parliament. What happens in this discourse? And the main interest for us to follow is the Sweden Democrats, as you probably most of you know, their main focus is immigration. So that's their main agenda item in the parliament. That's what they want to discuss. That is important for both the party and the voters that vote for the Sweden Democrats. So we want to see what happens with immigration in the parliament when they enter the parliament. So is there anyone who knows where this is? Exactly. So this is the Swedish Parliament Library. So the old statistical approach would be if I've done this like 10 years ago or 15 years ago, I would probably gone to this library. I would have drawn a sample of a couple of years or a couple of debates and then go into these debates and manually tag this to see, is this about immigration, is it not about immigration? And the problem by doing that would be, first of all, it would be very costly. Even though I draw a sample, I mean, if I want to follow evolution over time, I would still need to collect a lot of data. I won't be able to read all the protocols. And why would I? And then a reasonable question would be, why do you want to read all the protocols? You have all your research questions. You know what you're looking for. But in practice, that is not always the case. You think you have some idea. You want to test a lot of different hypotheses. Is there any MPs that are talking more about immigration, or is it difference between different types of debates? There are a lot of questions that can pop up when you actually analyze the material. So just drawing a sample would be perfect if I only want to answer one question, but if I want to explore and try to do a more refined analysis, getting everything analyzed is better for me. And also, if we do this manually, we would also have the problem of that the tagging or the manual annotation, it would be unreliable. It would be difficult to reproduce the same results. And then you can say, yeah, but you can have multiple coders that do the coding. Yes, but then it's just get more costly. So, I mean, whatever you do, you have these problems. So the paradigm shift. So what do we do instead? Is there anyone that knows where this is? So this is the Supercomputer Center at Linköping University. So this is the servers there where we do a lot of our research currently. So what do we do instead? So we use a probabilistic topic model, and that is for some of you maybe have heard about latent Dirichlet allocation. It's a probabilistic model to model text or model themes in large corpora. And the good thing why we chose to use this method is there are many reasons, but one is that it gives us interpretable results. So we can actually look at the model, see the things that it outputs, and try to understand, is this a good model for what we are doing? It's also unsupervised, so we don't need to do any tagging. in the beginning. We don't need to tag everything into immigration, not immigration. So what we did instead is that we gave this model, we developed the model a little bit so it could accept what we call our word seeds. So you put in a couple of words, in our case, immigrant, migration board. There's 7 of them, but I don't remember more than refugee, asylum has a different meaning in English, but yeah, we didn't put in asylum seeker, but you'll see we got that anyway. So in this way we put in some minor words, and we put those words out so every other researcher can criticize us and say, oh, those words are wrong, and we can remove them and try and do a sensitivity analysis. So we get this reproducible results. And then what we also did, so we use unsupervised methods to get interpretable results, and we also use an API from a text analysis corporation called Gavagai from here in Sweden, to do the sentiment classification for us, because we also wanted to study the sentiments in the parliament. And we could do it ourselves, but we had this really nice API, and we got an academic license, so they could help us to do that part, instead that we had to build our own sentiment classifier in Swedish. So this is the result. Unfortunately, it's in Swedish, but this is what the model captured. And this is how we looked at the model. So these are the most common words in what we call the immigration topic. So Sweden, humans, land, many, migration board, Swedish, asylum seekers, uppehållstillstånd, what's that in English? I don't. Resident permit. So those are the most common words that occur in when they talk about immigration. Yes, but none of those.
How many, 7?
7 different words. So Migrationsverket was one of those.
Okay, that's what it's called.
Yeah.
How do you define a word?
So we define a word as a token.
Clearly more common words that you're excluding, like en and och and so on.
Yeah.
You included ska.
Yes. So we can take the technical details. We removed the stop words, and ska, you could think of that as a stop word. You could think of it as a reasonable word as well. Sorry? Exactly. But then we also have the unique words, and those are the words that only occur in the immigration topic. So this is a way for us to see, are we capturing actual immigration in a good way? And we think we actually, none of those were the words that we used. This was learned by the model itself. And for us, this is a way of ensuring that the model is actually capturing what we wanted to capture. So it's model validation in a sense. And now when we have this model, we could easily plot how immigration changes over time in the Swedish parliament. So this is all the years. This is the proportion of usage when it comes to immigration topics. You shouldn't put too much weight on this, because this can change if you change some parameters of the model. It can scale up and down. But you can see the evolution over time from 1994 to 2017. And we can see that overall we have the interpellation debates that is relatively constant over time, and the subject debates that are also relatively constant. You can see a small jump in 2015, and that's the refugee crisis. So that would be quite expected. What is interesting, though, is if you look at the party leader debates, they follow a totally different pattern. So there we can instead see that they don't talk much about immigration in the way we have defined it up until 2010, and then it jumps and becomes much more prevalent within the within the party leader debates. So this is one example. And you can also see the jump there in 2015 during the refugee crisis. So, so could we have done this without using machine learning or topic models? Yes, definitely, but it would have been much more costly than it was for us to do it now. Especially, we could easily, I mean, if we just had data back to, I don't know, like the beginning of the 20th century, we could just continue this graph to follow this over time in a historical pattern. So the main problem here is that we don't have enough data back in history.
That is what is already so to say, online or
Yes, so this is open data from the Swedish Parliament.
you could scan and
Yes, you could. I mean, the protocols are there for all the way back, but you need to make them digital and make them digital in a way that we can use them for research. That's two totally different things. So this is one example on how we use this in a political science project. So now I'll go to a totally different area, but it's still in the realm of machine learning or probabilistic models for large-scale problems. So this is a project in computational journalism, and the question for all you is: can you see the story in this data? The news story. This is what all the journalists are confronted with when they should use the official statistics to find a news story. This is what they get. I mean, a huge spreadsheet. And this is even cut. It continues down, so it's even more. Yeah?
Yes.
Yeah?
Bicycle theft is going up highly.
Exactly. So you can start to work for us instead of the algorithm then. Yeah. Exactly. So here we see something interesting, right? So we see it's a low number and then it jumps up in the very end. So this is interesting for a journalist. Something has happened, and what we do in this project is we try to go through all the reported number of offences in all Swedish municipalities, and we also analyze unemployment, weather. I don't remember all the data sets now, but a lot of different data, and try to find those potential interesting news stories to make the decision, in a sense, on what can be potentially interesting in this data set. So this is how it looks if you go back when it comes to bicycle theft. This is in Jönköping municipality. So you can see, I mean, you still have some seasonal variations that you need to control for. But in the very end, we can see that, I mean, it is a spike, and it's controlled for using actually methods from communicable disease control or disease surveillance methods. So what we actually do then is we send this out to journalists and saying, hey, we found something. Maybe you're interested in this. And this resulted in a small news item in, I don't remember where it is, Jönköping's, I don't remember the Jönköpings-Posten. Yeah. So this is so we sent this to Jönköpings-Posten because it was in Jönköping, and they did what we think is a really good human-machine combination. I mean, we found the news lead. She digged a little bit more into it, found, contacted the police and said, hey, what is happening? And could dig more into this. So we could find the potential news lead, and they can dig even further into this. So it's an automated news lead identification. So what we're doing is that we try to do this automatic identification of potential stories. It's starting to come up, like they talk about digital watchdogging or computational watchdogging, to use statistical machine learning techniques to to watchdog municipalities or government agencies and so forth. So it's an emerging field, computational journalism. And actually, this has been running now for a year. So if you're reading, if you have read the last year, a local newspaper, and they wrote something about a peak in the crime, my guess is that it was we who actually found it, because it's around 100 to 200, 100 to 150, I think, news items written each month based on what we found in different small, not necessarily small, but local newspapers. And what is the importance here? It's still, I mean, we need to use more or less unsupervised techniques here. We don't have a pre-classified nice training set saying this is interesting news, this is an uninteresting news. What we have is it's a collaboration with me and Jens Finnes and Leo Valentin that are data-driven journalists. So they can say this is interesting from a journalistic point of view. And then I try to create models that can actually capture this, that is interesting for the journalists. And it's also, interpretability is really important here. I mean, we can't classify like a time series and say, this is an interesting news story for you. I mean, the journalist would like, if they can't see it, I mean, if you can't see a big jump or you can understand what is the news story, they won't use it. So it's extremely important that we find something that the journalist easily can see this is the story, and they can dig into it and add more, I would say, to dig even deeper into this potential news stories. And it's and we are also looking into APIs now to do the writing of a small news item article for the newslead automatically. And we could try to implement it ourselves, but I mean, we're not an expert in natural language generation, so we would like to use an API for this. And there are a lot of small anecdotes in this project, like when we found an anomaly that Brottsförebyggande rådet hadn't been able to find before us. So we found it before they could look into this anomaly. So the takeaways from my talk is, I think unsupervised methods are becoming more and more interesting, especially in the social sciences, when you don't have this nice training data. But you have a large data set and you want to model it somehow to answer our research questions. And that also, what I think is more and more interesting is how you can use this to do confirmatory analysis. How can you confirm a hypothesis or test theory on a large data set using these techniques? And also the interpretability is really important to be able to use it in a good way in the social sciences and the humanities. And I think the day when you could be one scientist that did the project on your own without this mix of different competence, I think maybe it works today, but I don't think it will work in 5 years' time. I think we need to have a broader combination of competences in social science and the humanities research projects. So that was my ideas.